All right, at this point, you should be comfortable with the basic process of U substitution. You should have completed the first worksheet on U sub called U substitution 1. What we're going to go through on this video is why the notation that we use in U sub works out to a legitimate mathematical process. And so let's go through one problem fairly quickly. So let's go through this problem, 3x times 5x squared minus 1 to the 7th power dx. And so we're going to work this problem pretty quickly. We're going to choose for u to equal 5x squared minus 1. And let's make that a little bit neater for you. 5x squared minus 1. Du then is 10x dx. So as we saw in the last video, we're going to pull the 3 out. We're going to put 5x squared minus 1 to the 7th at the beginning. We're going to put the x next to the dx. We're now going to multiply by 10 inside and 1 over 10 outside. So we get 3/10 integral u to the 7th du, which is now 3/10 times 1 over 8 u to the 8th plus c, which is 3 over 80 times 5x squared minus 1 to the 8th plus c. And so this is the answer. Okay, so there are a few things that are problematic here as far as the notation being formally correct. So it's okay to put u equals 5x squared plus 1 and then replace the 5x squared minus 1 with the u in the problem. When we define du to be 10x dx, we defined it in the last video to be the derivative of u times dx, which is reasonable enough. The problem is, at this stage, du disappears, which is probably, if you had questions on the first video on this, the question would be, why does the du go away? And so du stands here as the derivative of u times dx, but then we're treating it as though it means with respect to u in the next step. So when you do the antiderivative of u to the 7th with respect to u, you get 1/8 u to the 8th. And so it's a little bit questionable as to how legitimate that is. And so for this to work, we can check that it works by taking the derivative of our answer and showing that we get what we started with. And so let's go through that process first. So if I have the derivative of 3 over 80 times 5x squared minus 1 to the 8th plus c. So the d dx symbol, in case we forget, that means take the derivative of what's in the brackets with respect to x. So if we do that, if we take the derivative of that with respect to x, we bring the 8 down. And so what happens is we get 3/10, because the 8 cancels with the 80, times 5x squared minus 1 to the 7th, and then times 10x because of the chain rule, and then plus 0 because the derivative of a constant would be 0. Then when we do that, we would want to simplify it, and the quick simplification we can make is we can cancel the 10s. So we get 3 times 5x squared minus 1 to the 7th, and then times x, and then normally we would put the x at the beginning next to the 3. And so we get 3x times 5x squared minus 1 to the 7th. And so it's right because this matches this. The integral and the dx, those are the operators in the problem. So that's like telling you what to do. That's like if you were saying, okay, take the square root of this. So it's saying to take the antiderivative of what's underlined in green with respect to x, and then on the right-hand side, what's underlined in green is what we ended up with when we took the derivative of the answer. And so we are correct. Now let's look at exactly how this matches up. So if you notice that the original problem, so kind of step 1 over here is the original problem, except for the integral sign and the dx, that's exactly the same as the answer here. Okay, and then the next step on the integral, if we take out the integral and the dx, this 3 and then the 5x squared minus 1 to the 7th times x, that's exactly the same as what's here. Okay, and so again, except for the integral sign and the dx, which is the operator, it's exactly the same. The third step, working the integral, is exactly the same as the previous step over here. And the answer on the integral, which no longer has an operator, is exactly the same as the original problem over here, except for its operator, which is the take the derivative part. And so what happens is we've exactly reversed the chain rule. So we start on the left with 1, 2, 3, and then we go to 4. That's exact reverse of what the derivative chain rule is, where we start with 4 and go back 3, 2, 1. And if you notice these two steps, the part with the u and the du, that lifts out of the problem. We could technically go from step 3 to step 4 because it's an exact reverse of a derivative. And you're welcome to do that. The u substitution, the fact that it's a little bit questionable as to whether the notation's okay, the reason we will allow that is because it's exactly the reverse of the chain rule. The reason the du goes away is because the du is the derivative of the inside. So the du is what we would have gotten out of the chain rule. On the right-hand side, when you take the derivative, you put that in from the chain rule. So when you reverse the derivative, the 10x disappears, except it's weirder when it's there and you take it away than when it's not in the original step and you put it in. So this is why we'll allow u substitution to be written the way it is. It's a way to get us to reverse the chain rule without really necessarily thinking that that's what's happening while we're doing it. That is what we're doing the entire time. We're reversing the chain rule. It allows us to do a lot more complicated problems. We should be, like I said, pretty comfortable with the first set. We're going to move in the next video into some more challenging forms, some places where it's a little bit harder to tell what to do. But that's it for this video. This is why we'll allow u substitution to be written the way it is. One other comment is there are other notations for u substitution that are used, some textbooks and some other instructors, and many students will do it in different ways. That's okay if you have a legitimate way to do u substitution, as long as what you're doing works mathematically every single time, then you're allowed to do that. You don't have to do it exactly the same way I'm doing it. The way we do it here, I think, is easier when we get to harder problems. Also, it's the exact reverse of the chain rule, which is another good way to show, a good reason to show it this way. Okay, that's it for this video. Thanks for watching.